Hello. It's nice to know when certain applications have reached a specified current, and this is an easy way to do it. These voltage monitors are only about $13 shipped. They'll read 0 to 100 volts, and what I've paired is this ACS 712. It's a 5 amp version, and I recommend everyone buy the 5 amp version. If you need more current, then you can run the sensor in parallel with a shunt or a wire to make it various other current size. These terminals aren't really good. You can buy versions of these which are 30 amp, and they don't come with terminals much better than this. They can't really handle that, so I generally suggest you run at least a little bit of a shunt wire if you're running more than 5 amps. But anyways, I've modified this thing slightly. First thing is I put a little hole in here, and that's because I'm putting 2 amps into this right now, and you see this little red light come on, and here's the output relay being switched. They don't put a hole in there, so they have a light that no one can ever see. If you go up from the bottom of the case, it's 1.6 inches up, and it's about 0.415 inches in to the center, and it's a 3/16 hole, or a little bit smaller, whatever you want to put in there. But that's a pretty good dimension on this. So a lot of my applications are water heating, and if you there's nothing worse than direct connect heating element to a solar panel, because it's a fixed resistance, and as the light level drops, the voltage drops dramatically, because it's current times the resistance, which gives you the voltage, and it's voltage times the current, so it's a square of the voltage, and dropping the voltage a little bit really drops your power. So instead of just a single fixed resistor, you could have 2 resistors or even 3, and you could switch in at different points. That even works for my little MPPT water heater controls, because these are generally good for about 600 watts, maybe 700 watts, but the board isn't really designed for a lot of current, and you need some more FETs if you want to operate at higher currents. But you could put 600 watts into this and 600 watts into a fixed resistor, and you're not having to make this any bigger. So after you get up to so many amps, it switches in a fixed resistance, and then this drops back and PWMs in whatever extra current is needed for a second heater. Like I said, that's a 2 heater system, and in a direct connect, if you need, say, like a 10 ohm resistor, which would be ideal for your panels. Many heating elements are dual, which means they're just 2 resistors in parallel of equal resistance. You can power one with the solar panel all the time, and when the current gets high enough, this can switch a relay and throw in a second one. So it has 2 power points that it matches up to, giving you a lot more efficiency at lower light levels. But let's look inside here. This is your little LED. This is the relay. You got a nice little terminal block here. This is 12 volts, 12 to 30 volts power going in. This is your common ground, and this is the signal. If you actually had another one of these that you wanted to switch at a different level, you could just run a jumper wire from this over to the second one. And like I said, this is 2.5 volts is standard where it comes out of here. This has to be supplied with 5 volts, and you generally get exactly half the voltage. So to set this up, this one side says set. You press that and you work this digit, that digit, that digit. This is the voltage it turns on at, and you hit it again, and you go through these. This is the voltage it turns off at, and they have a little offset you can put in here. We're at the very bottom of the range, and it's actually off 0.2 of a volt. So I put this 0.2 in there, and that corrects it up so it reached 2.5. Before it was reading 2.3. This is delay. This is the longest delay I could put in. It's only about 10 seconds. And this switches, it turns on high, just whether it's like for a heating or cooling application, or and hit it once back and you're back to the 2.5 volts. Now here's the modification you have to do to the board. So these are what they call DuPont wires. I have female on this end, male on this end, and you can use these male tips just to solder to these connections. One is ground. This is the signal, this VIN plus. That's the signal coming from the sensor. This is your 12 volts over here. Now we have to supply the sensor with 5 volts, and so we supply it from the center common pin of the relay, and we've done that by jumpering. This is 5 volts over here, jumping it over to the center contact. That also gives you 5 volts coming out to operate your solid state relay. You could connect this directly over here and not jumper this if you had an independent power source. But this board has its own little 5-volt regulator, and it's a convenient, slick little system. So you got the 3 wires there going right over to your sensor, and that's it. Pretty convenient. So let me show you. Like I said, this is your 12 volts coming in. This is the normally the common contact for the relay. This is the normally opened, and so when we turn it on, that sends 5 volts out. You're actually seeing people don't realize it, but LED lamps are really just solar panels. And you notice that it's generating voltage, a negative voltage. And if we cover it up, it'll drop down. And this is your signal. See, it says 2.5 volts over here, and we're supplying 5 volts to it. It divides it in half. These can go plus minus, but we're only interested in the plus side. And that's it. Now, current sensors like this have these little Hall effects too, and if you connect a voltmeter onto the common side, you can go through these pins. One will be 0 volts, that's your common. One will be 5 volts, and that's the power going to this. In this case, it's 3.3 volts, which is another common computer voltage. And the last one, which will have half of that voltage, is your signal. So you could actually use one of these, but the unfortunate thing is this is a 50 amp version, and you're only going to get less than a volt going to your volt change, so that makes it pretty hard. This one you have basically 9 or 10 stages that you can set it to, and you wouldn't have that much with the other one. But like I say, if you have this sensor, get the 5-volt one. You can always bridge a wire going across. Make these connections really good, because you're still going to be sending a lot of current through this. And depending upon the length, you could make this 10 amp or 25 amp or even just you know, something like 7. But it's 2.5 volts normal output, and then basically 0.18 volt for each amp, or 1/10 of a volt for each half amp. So you can adjust up to each half amp, but it works pretty neat. And that's it. So you can use this to power a second heater once you're up to a certain amount of current. And you know, if you've got a heater and you've set up your system with a particular heater already, and you've added more panels, this is a good way to up your system. But you know, less than $20, you can look at the current and switch a relay on and off. So thanks for watching.